Hydraulics works because of Pascal's law. Pascal's law says that pressure applied to a confined liquid is fully transmitted in all directions and acts with equal force on all surfaces. So let's explain that a little bit more. So you can see we've got a container over here, and it's closed everywhere except for where that piston is. Now the piston seals it, but we can move that piston down, okay, or we can put a force on that piston. So here we've got 10 pounds being pushed on that piston, which goes directly into the fluid that's in that container. Okay, it could be water, it could be oil, it could be vinegar, it could be any substance. Usually oil is the fluid of choice. But we're pushing down with 10 pounds on that little piston. Now, the question is, what is the force on each square inch of the container wall due to that 10-pound force? Well, I'm pushing down with 10 pounds. That means that everywhere else is going to experience 10 pounds of pressure. So, 10 pounds of force on each square inch. So then, how much force is being exerted on the entire base of that container? Now the base of the container is 20 square inches, so we have to multiply that force, that 10 pounds per square inch, times the 20 square inches. We end up with 200 pounds. So this 10-pound force is converted into a 200-pound force because of Pascal's law. So this principle is also used in what we call a hydraulic press. So in this case, we've got two pistons. So one on the left is a little bit smaller, one on the right is much bigger. And we can push down on the left with 10 pounds of force. Because the area is bigger on the right, it's going to push up with more force. All because the pressure inside of that liquid is going to be the same anywhere in there. It's pushing on the container walls with the same amount of pressure. So we push down on the left, it's going to want to move up on the right. So here we've used a small force over a small area to produce a large force over a larger area. You've seen this before with levers, right? Instead of distances, we're using areas. We have a mechanical advantage here of 10. Not too shabby. Now we do have a trade-off. If you remember from Simple Machines, there is going to be a trade-off here, and that trade-off is distance. So we can push down with 10 pounds and get 100 pounds of force out of it, but we're going to have to go a further distance with that 10-pound force than the 100-pound is going to move. So we put in more distance than we get out, but we get a much larger force. So we're going to try now a hydraulic press problem, and sometimes it's called a hydraulic lift because you are lifting something typically, but hydraulic press is the more common term. So here we're working from the equation that pressure is equal to force over area. So keep in mind, pressure is the same throughout the fluid. We're going to use that principle. So if the pressure at point 1 is going to be equal to pressure at point 2, we know from our equation up there that force over area at point 1 is going to be equal to force over area at point 2. Using this information, I'm going to plug in this data that we have, 20-pound force on the left over a piston whose diameter is 1 foot, and then on the right at point 2, we've got the diameter of 6 feet, and we want to know what kind of force we can get out of it. And so we got small force over small area and big force over big area as the output. So, what is the mechanical advantage of this system? How much force can we lift or apply to that that weight on the right? How much can we lift? So again, we're going to take that F over A is equal to F over A, plug in our values. Remember, you need to calculate the area because it's not given. So using the equation that we've used in the past, right? Pi r squared for our area, plug in those values, and solve for F2. So with 20 pounds of force in this hydraulic press, we can lift 716.5 pounds. Mechanical advantage, remember, is the output force over the input force. So 716.5 divided by 20, this is a mechanical advantage of 35.8. That is incredible. This is why we use hydraulic systems, because we can get fantastic mechanical advantage out of simple systems and with very little loss of efficiency.